Hey gang, Matt here again. How you doing? Great, so this is video number 2 in our trilogy. This is Europa Strikes Back, essentially. Actually, we're gonna call it Potential Science Objectives. In the last video we talked about, I kind of went over some basic stuff about Europa and very quickly about Jupiter as well. And I talked about the InSPIRESS mission too. This video, we're gonna piggyback on the information that we just learned and talk about some potential science objectives based on things we know and don't know about Europa and Jupiter. I'm going to focus on Europa for this, but there's also Jupiter as well. So, as PJ and I have talked about in videos and in your class as well, Europa is a very hot topic right now. It's very in the news as far as any planet is in the news. But at NASA, Europa is a very, very hot topic, and it's because of, well, there's a few things happening. There's, number one, is scientists have always believed that there's this subsurface ocean, and that it could potentially have life, and that it's the most promising planet or moon in the solar system to have life. The second thing is the recent discovery of these plumes. This was like 2013 that they discovered these plumes, just last year. And so this gives us an opportunity to sample the subsurface ocean without actually going in the ocean. And the third one is the new launch vehicle that NASA is building allows us to get to Europa quicker and with more mass to do a mission. So that's why Europa is really is a hot topic right now, is because of these three things that are happening. And so NASA is spending a lot of money looking at Europa, and they're going to have a mission that goes there. It's just a matter of what they're going to do and what the mission is going to look like. So NASA, like PJ said, PJ and I said in our very first introduction video, the way that these missions are formed is the scientists get together and they vote on potential objectives. This is the list of objectives that the scientists came up with for Europa. And I don't know if they're in any particular order, but I'm just going to go through them. And this is actually, I copy and pasted this from a NASA article. And so this is their actual wording, and I'll explain. It's kind of funny. So what are the characteristics of Europa's ocean? So Europa has a subsurface ocean. What's it all about? Is there life in it? How deep is it? How much water? Blah, blah, blah. What are the characteristics of the ocean? How thick is the icy shell? I talked about in the last video. There's the great debate of thick versus thin ice, right? How thick is this shell? Is there near surface water within the shell? Are there lakes of water that are like there's ice all around and there's just a pocket of water? Does that exist within the shell? What is the global distribution of the geological features? The features, like those lineae, and then there's the chaos areas that are on Europa. What's the geological distribution? How are they formed? Why are they formed? Is liquid water involved in the surface feature formation? Kind of relates back to the previous question. Those geological features, does the liquid water below the surface, does it form these things? Is the icy shell warm and convecting? So this is back to the thick versus thin shell debate. Everyone agrees that on the very top there's a really hard icy shell, right? But below that, is there a I use the term warm loosely, icy shell that convects, that allows the ice to shift around? On Earth, our rock, actually, we have rock that convects, that kind of moves very, very slowly, but it still moves. So is the same thing going on Europa, but with ice in this case? And what does the red stuff, this is the way NASA worded it, what does the red stuff tell us about ocean composition? So is the red stuff on the surface, is it a result from outgassing? Most of the red stuff occurs near these lineae and stuff. Is it stuff escaping from within the planet? What does this red stuff tell us? So are the salts and sulfurs and magnesium deposits, these salts, these things on the surface, did they come from within the planet? Or there's the one impact crater they really believe came from off the planet, but the other dark spots on the planet, where did they come from? Did they come from within the ocean? How active is Europa today? Active, like seismology active. You know, they know it's being flexed and stuff. Is there anything else going on? Is the ice convecting? Is there they believe that there's a rocky part to the planet as well. Is there tectonics going on there? Are there volcanoes down there that are erupting, that are heating the water as well? So they don't know. They want to know that too. What is the plasma and radiation environment at Europa? Excuse me. So Europa exists within this huge magnetic field from Jupiter, and there's a plasma interaction because of the radiation in the magnetic field of Jupiter. How does this, how much impact does Europa have? How does Europa interact with this plasma and radiation environment? And what is the specific nature of the organics and salts at Europa? These organics and salts that these flybys that they've had, we've had a few flybys, and they've looked and they've found these organic materials and these salts. There's the one impact crater that they want to know, where did it come from? That's weird, okay? And these organics got placed there by something else. They want to know where that one is. And then there's the salts that go back to the red stuff. What are these salts? Were they deposited from something previously from off planet, or do they come from within the planet? So what is the specific nature of organics and salts at Europa? And how big are they? Are there organics? You walk up to them, they shake your hands, whatever. There's a movie actually called Europa Report. You can get it on iTunes right now. It's not a very bad movie. It's not a very good movie either. It's got the guy, one of the guys, there's one guy you'll recognize in it. He was the, what was the movie where Matt Damon had like a robot suit that he put on? Elysium. He was the bad guy in Elysium. He's in the movie Europa Report. He was also in District 9, that guy was, I think. Anyway, but he's the only actor I recognized in the entire movie. But it was decent. It kind of gives some cool animations about Europa if you want to watch it. It's a 90-minute movie, so it's probably shorter than my videos. But it's kind of spliced up. It's interesting how they put it together. But it's very fiction, okay? And but so you'll see, you might like it. I don't know. So science categories. All these different questions that scientists have, I've reduced them down to different categories, and the categories are kind of based on location. So we've got surface and atmosphere, okay? So measurements on the surface and measurements in the very thin atmosphere that Europa has, very thin, very sparse atmosphere. Then there's measurements that are internal structure measurements, so measurements down below, subsurface measurements, okay? Then there's measurements that they want to take in the plumes. Those are actually in the atmosphere, but I'm considering them different because the plumes are kind of coming out from within the planet. So there's measurements in the plumes. And then for us, for our mission, you can take measurements at Jupiter. And again, Jupiter is the weather king, okay? It's the size king too for the solar system. So we've got surface and atmosphere measurements, internal measurements, internal structure measurements, and then plumes, and then Jupiter. So Europa, atmosphere and surface. What are the different things you can look at? On the atmosphere, you could look at atmospheric properties and composition. Like I said before, there's reactions that occur on the surface that the scientists believe that form the atmosphere. Is this really true? What's going on? How does Europa have an atmosphere, essentially? So that's properties of the atmosphere. What's its temperatures, the pressures, blah, blah, blah. Those are properties. The composition is what is it made of. So atmospheric properties and compositions. Surface, also properties of composition. What, properties, how cold is it, how thick is it, stuff like that. Those are properties. How hard is the surface? Hardness is a property. Composition is what is it made of? What are the constituents? What are the elements that make up the surface? The dark areas. And then all the rest of these are basically properties of composition. The dark areas, those are specific parts of the surface. The comet asteroid impact area, what are the properties of composition of this area? The age of the surface. There's a big 20 million years old to 180 million years old, big swing. And they just settled on 65. They're like, oh, whatever, 65. So what's the actual age of the surface? The surface features, lineae, chaos, etc. What's going on these locations to create these things? And does it relate to what's going on below? Magnetic field, again, it's Europa has an induced magnetic field because of Jupiter, which is right next to it. And how strong is this magnetic field? Does the magnetic field change as it gets closer to Jupiter and further away from Jupiter? Does it change as Ganymede goes by and as Io go by? Does it change with tides? Because they think the magnetic field is a result of the moving ocean below. So does the magnetic field change with the tides? Very interesting stuff. The temperature, that's a basic measurement. That's a property measurement. How cold is it on different locations on Europa? Internal structure-wise, I'm going to skip over here. And internal structure-wise, you can look at internal structure. Scientists, there's certain scientists in this country, all over the world actually, that their entire job, they want to know the internal structure of everything. What does it look like down below? You guys have seen what Earth looks like, what scientists think Earth looks like down below, right? We'll talk about how they know these things in the next video. But internal structure is very important to a planet and to a moon. Knowing what's going on inside will tell you why things are the way they are outside. So there's the subsurface ocean. Is the ice thick or thin? Are there subsurface lakes? Is the ice connected to the surface or not? Scientists pretty much know that it's not, but why is the motion so slow? Is the ice convecting upward as well as moving around? That goes back to the warm ice debate. There's things you can look at there. Heat flow. Heat flow is a property of a planet. You ever been in a cave? A cave is always like what, 65 degrees? Because inside the Earth, you get to if you go deep enough in the Earth, you get to a certain temperature. If you go a little deeper, you probably get really hot. But once you get so many feet or so many whatever below the surface of the Earth, it's always the same temperature. Is that true on Europa? Is there heat flow? Is there heat that comes from the deep within the planet that rises through the planet itself? That's called heat flow. Very important to scientists. Scientists want to know all this. Scientists want to know this on our moon as well, heat flow within our moon. And then the ice flows. Again, the ice flowing, they think it comes from below and actually flows up to the top and replenishes the surface ever so slowly. The plumes, again, the plumes are at the South Pole, and basically it's just shooting jets of water and ice out into space. And they think there could be biologicals in there too. They'd be like, that would be terrible if you were like a little bitty amoeba. You're like, yay, I survived Europa, and then you're like, ah! Get shot out into space. That would just suck. Anyway, so the plumes, properties and composition. What are the properties of it? Temperatures, particulates, the flow rate, when does it occur, stuff like that. The composition, is it just water and ice? Is there anything else mixed in there? Are there biologicals? Are there salts? Is there an octopus? Who knows? Biologicals, life in the plumes, and the velocity, mass, flow, etc. Again, velocity, mass, flow, those are properties. Biologicals are composition. So Jupiter, the fourth, Jupiter. You can look at atmospheric properties and composition of Jupiter. The atmosphere, very, very interesting stuff. Very fast-moving atmosphere, high winds, lots of lightning. There's only a few planets in the solar system that actually have lightning. Jupiter's one of them. What is it? Venus, Earth, Jupiter, Saturn? I think that's it. So Jupiter's one of the four that has lightning. Go study it on Jupiter. And it's different lightning because Jupiter's made up of hydrogen and helium, a lot like our sun. So Jupiter, so what's the lightning like on Jupiter? Go study it. The weather, the wind speed, the lightning. There's lots of weather, the different jet streams on Jupiter. Storms, big storm. That's the most interesting feature about Jupiter is the Great Red Spot. This huge, three-size, triple Earth hurricane that's been going on since we've seen it. For at least thousands of years. And then right below it is the white spot, right near it. The smaller one, not as well known. Remember, it's the Steve Young to Joe Montana. So those are some potential science categories. Now you'll notice that I've said properties and composition time and time and time again. This is basically there's two types of measurements. There are properties of something. How cold is it? How warm is it? What is it? What is the velocity? What is the wind speed? What is the the flow rate? What is the charge? What is the, what are different properties? What is the pressure? What is the, those are properties. There's a lot more of these I'll talk about in the next video. But so properties are what, how is a thing defined, right? Those are properties. Now, the composition of something are the constituents, the constituency. The constituents of something is the composition. What is it made of, okay? Does it have hydrogen? Does it have carbon? Does it have oxygen? Does it have nitrogen? You know, what is it made of? So most measurements that we take, most scientific measurements, most science that we do at other planets that we do on Earth, can basically be boiled down to two things: properties and composition. So as you're thinking about your science objective, you can reduce it down to properties and composition. You don't have to study both of them. You can just study composition. You can just study properties, or you can study a combination of the two if you like. But there's lots of different properties that you could study about different things. And then composition-wise, how deep, how much, how thorough you are with your composition measurements makes it more difficult as well. So, but there's basically two types of measurements: properties and composition. And then from that, we've got the different categories at Europa and Jupiter. So this video was just to get you thinking about, get the juices flowing in there. The last video, the introduction, or the overview video of Europa and Jupiter, that one was to talk about, give you the background, to tell you what we do know and what we don't know about Europa and Jupiter. This one is just to say, oh yeah, you could study that. That could be your science objective. And if you have any questions, we'll talk to you about this in class. Or you can email us, or talk to your teachers, or look at previous InSPIRESS payloads, what they used for science objectives. If we will come to you in about a week, and if we think your science objective is too big or too small, we'll let you know, and say like, why don't you, yeah, at the team progress report, we'll let you know what we think. If your science objective is too big or too small, or too much, you're trying to do too much, let's scale it down a bit, And but we don't want to tell you too much right now. We want you guys, this is your team's deal. This science objective is going to define your team. It's going to define what you guys are studying for the next, for the rest of the semester. It's also going to define your identity. That's why everyone's watching this, right? Because your science objective is going to determine your team name, your team logo, your team slogan. It's going to be your team identity. So it's something. The science objective is something that everybody should be at least mildly interested in. So spend some time on this. Think about it. Sit down, throw ideas around. Whatever you do, whatever you guys have to do, brainstorm. But you want to take this seriously and come up with an interesting science objective that all you guys are interested in, that all you want to pursue. You don't want to just be like, well, okay, we'll do this. Let's look at, whatever. You want to make it's something that you're interested in, so that you will be able to pursue this and do the work that's required. We're not going to prescribe a science objective to you. You guys come up with it. So, again, have any questions, let us know, or let your POC know, and we will see you guys shortly. And if you're on the design team, you got one more video, almost there. Thanks.